The objective of this lesson is to divide multi-digit numbers using the standard algorithm. It is important to understand division at a deeper level to solve problems with accuracy, efficiency, and flexibility. Students should be able to use the standard algorithm for long division and be able to explain each step. Let's divide 741 by 3. The three methods we will use are modeling with blocks, recording all the zeros, and the standard algorithm. To represent 741, use 7 flats for the hundreds, 4 rods for the tens, and 1 cube for the ones. We will split this number into 3 groups. Make a division bar with the dividend of 741 inside and the divisor of 3 outside the bar. Set up the problem the same way for the traditional method with the division bar. To be efficient, divide the larger blocks first. 7 hundredths divided into 3 groups is 200 in each group, with 100 left over. 700 divided by 3 is 200 in each group, leaving 141 after you subtract. Regroup the 100 left into 10 tens, making 14 tens altogether to be divided into 3 groups. 14 divided by 3 is 4 tens in each group, with 2 tens left. 141 subtract 120 is 21 left. Divide the tens next. Bring down the 4 tens. This 14 represents 14 tens. 14 tens divided into 3 groups is 4 tens each. 4 tens times 3 groups is 12 tens. 14 subtract 12 leaves 2 tens. Regroup the 2 tens into 21s to go with the 1 you already had, making 21 ones. 21 divided into 3 groups is 7 in each group, with none left over. Divide the ones. Bring down the 1 in the ones place. This 21 is 2 tens and a 1, which is 21. 21 ones divided into 3 groups is 7 ones. 7 times 3 equals 21. 21 subtract 21 equals 0. Now we add the partial quotients of 200 plus 40 plus 7, which is 247 for the total quotient, or your final answer. Each method of dividing 741 by 3 shows the correct answer is 247. In long division, you split up the greatest place value first. Students should understand why they are bringing down a number. It is a step that helps them regroup and split up the next place value. The standard algorithm is a more efficient way to divide, focusing on only one place value at a time. To demonstrate understanding, do problems with a 0 in the dividend or the quotient. Let's use the standard algorithm to practice some of these situations. Let's do 2,240 divided by 14. We have to divide the hundreds first, because 2,000 is not enough for 1,000 in each of the 14 groups. There is only one group of 14 in 22, so 14 times 1 equals 14. 22 subtract 14 equals 8. Those 800 are regrouped into 80 tens. Bring down the 4 tens. Divide the 84 tens by 14, which is 6. 6 times 14 equals 84. 84 subtract 84 equals 0. Students should realize at this point that they haven't determined the number of ones in the quotient. 0 ones divided by 14 is 0 ones. Without that 0, the answer of 16 would be unreasonable. Students with a deeper understanding may just put a 0 in the ones place, so the digits hold the correct value: 100, 6 tens, and 0 ones. Let's do one last problem. 4,224 divided by 3. 4,000 divided by 3 is 1,000 in each group. 4,000 subtract 3,000 is 1,000 left. Bring down the two hundreds. This 12 is really 12 hundreds. 12 hundreds divided by 3 is 4 hundreds. 4 times 3 equals 12. 12 subtract 12 equals 0 hundreds. Bring down the two tens. 2 divided by 3 is 0 tens. 0 times 3 equals 0. 2 tens subtract 0 equals 2 tens. Now bring down the 4 ones. This 24 is really 24 ones. 24 divided by 3 is 8 ones. 8 times 3 equals 24. 24 subtract 24 equals 0. The quotient is 1,408. It is critical to put that 0 in the quotient in the tens place to get the correct answer of 1,408 rather than the unreasonable answer of 148. The objective for this lesson was to divide multi-digit numbers using the standard algorithm. We met this objective by dividing with blocks, reasoning with place value charts, and using the standard algorithm.